As per Kaylee's request, I'm going to try to talk louder in videos from now on. So talking loudly to an empty room feels really weird to me. So we'll try and see what happens. Today we're going to solve what are called literal equations. And literal equations are really nothing more than equations with more than one variable in them. For example, the two that you see, A and B. They both have two variables. A has x and y, B has m and n. So what we're going to do with these is isolate one of the variables. That is to say, get one of the variables by itself. So what we are going to do with this is, the first one we're going to try to isolate the y. We're going to get y by itself. Now, last week, I showed you a little bit of a flow chart that we could use to help determine the order in which we do things. That flow chart can really help with these. So what we do when we start these is we start with y and determine what we are doing to the y, thinking of order of operations. And now here, we are multiplying the y by 5, and then what's happening is we are adding 10x to that. We're not just adding the 10, but we're adding 10x to that, and we're getting 80 for a result. So we're going to work backwards. And this helps us in solving these literal equations especially. So to undo the addition of 10x, we are going to subtract that 10x from both sides. So we're going to subtract 10x. Now, in our work so far this year, 80 and 10x are not like terms, so we cannot combine them. The 80 does not contain an x, so we cannot rewrite that as 70x because 80 does not have an x. So what we need to do is keep that separate. So we can just keep that as 80 minus 10x. If you are one of those people that really need to have the x first, just be careful that you're writing it as negative 10x plus 80. So then to undo the multiplying by 5, we're going to divide by 5. Now, one thing that you have to be careful with, and if we divide both sides by 5, okay, and we've seen problems like this already when we've talked about the distributive property. Dividing by 5 is the same thing as multiplying by 1/5. What we have to be careful to do is to make sure we divide both of these by that 5, or multiply both of them by 1/5. So, as a result, 80 divided by 5, well, that turns out to be 16, and 10x divided by 5 is 2x. And that is solving that literal equation for y, isolating the y. Now, in the second one, we're going to do the same thing, except we're going to isolate the m. So perhaps doing the flow chart to help, think order of operations, what's going on with the m. We are multiplying by 2, and then subtracting 5n. And we're getting 4 for a result. So we are going to work backwards. To undo subtracting 5n, we add 5n. So we are going to add 5n to both sides. So in that case, we have, as a result, 2m equals, again, we cannot combine the 4 and the 5n because they are not like terms. So we're going to rewrite that as 4 plus 5n. And if you'd rather write the n first, you can write it as 5n plus 4 means exactly the same thing. Now going back to our flip chart, our flow chart, we're going to undo multiplying by 2 by dividing by 2. Okay? So we end up dividing by 2. And once again, if it helps you, you can think of this as 1/2 times that top, if it helps you. Otherwise, make sure you are dividing 2 into both of those terms. That being separated by the addition, you need to do that. So, to distribute, 1/2 times 4 becomes 2. 1/2 times a 5n becomes 5/2 n. And that is the resulting equation when solved for m. Okay, in the next one, we have a bunch of variables and no numbers. So, but we're going to do the same thing. Again, I'm a big believer in this flow chart really helping you. So what we're going to do is we are going to think order of operations. We're multiplying by p first, and then we are adding r to that term and getting negative t for a result. So to work backwards, to undo the addition of r, we're going to subtract r. And once again, t and r are not like terms, so we need to write them separately. Negative t minus r, and that is equal to px. And then to undo multiplying by p, we're going to divide by p. And nothing really cancels there. So if we have negative t minus r, we can write that entire expression then over p. And that is our resulting equation. Negative t minus r all over p. Now D poses an interesting problem because we have two x's for which we want to solve for. So what I want to do is, what if a and b were actual numbers? What if we had, say, 5x minus 2x instead of a minus b? Well, when combining these two, all of you should know that that's equal to 3x. But let's think about how we arrive at 3x. You know, we basically, all we're doing, using the distributive property, what we're doing is subtracting the 5 and the 2, 5 minus 2, and then the x is just kind of hanging along for the ride. That's actually the distributive property that we're using there. It's just in the opposite order of what you would think, or what we normally do. So we're going to do the same thing here. We're going to take the values that are attached to the x and set them off in parentheses. You know, just like what we did here, we're doing up here. We're using that distributive property. The only thing is now we cannot combine the a and the b. We cannot take a minus b and simplify it anymore. Well, let's say this was equal to 12, and if that were the case, then we would divide by what's being multiplied by x. So, we're going to do the same thing here. What is being multiplied by x? The entire expression a minus b. So that's what we're going to divide both sides by, and then our result, x is equal to c over a minus b. Now in our next video, we're going to take a look at solving some formulas for different variables.